Mr. Musk, there are a number of stranded people during the zombie apocalypse. Do you have any ideas on how these people can be rescued?
I had an idea, but AAE251 Aircraft Design Team A03 from Purdue University paid me a large sum of money, and I've actually brought them here today to discuss their plan. Take it away, boys. Hello, this is Cody Martin with Team A03, and today we'll be presenting our aircraft design for post-apocalyptic scenarios. On this team, we have Jacobo, Charlie, Blurton, Dylan, and Aubrey.
Given the guidelines of this project, we have determined 5 distinct stakeholders. These stakeholders include survivors of the zombie apocalypse, pilots, Purdue University, the Zucro Labs, and the Safe Haven camps. With these stakeholders, we were able to develop requirement statements for our proposed aircraft. These requirement statements for the aircraft are included but not limited to having the size of a Boeing 737 and being able to take off and land within 300 feet.
For the risks, the team concluded that zombies pose the most glaring risk to take case into this scenario. On the other hand, wear and tear and passenger complications were deemed the most likely, as this scenario would push both human and machine to the limit. They were thus prioritized in our solution. Some other minor risks considered were human error, mechanical malfunction, or faulty construction, mostly derived from the lack of expertise a potential crew made up of survivors could have. Finally, we consider risks like other aircraft, turbulence, and bird strike as unlikely and thus less relevant than those mentioned before.
In order to generate some ideas, we first looked towards aircraft which fulfill the requirements set before us. From this, we developed 3 generalized models. The first being a VTOL aircraft similar to the V-22 Osprey, the second being the Tupolev Tu-144, and the last being a bush plane similar to a Cessna 172. With these 3 aircraft in mind, we evaluated the pros and cons to each and discovered some significant challenges certain models will have. First, the VTOL Osprey model is incredibly complicated and difficult to fly, and it has a myriad of issues and must be serviced frequently. The Tu-144 model, while exceeding expectations in weight and range, it is likely overkill for our specific needs. This leaves the bush plane model. This model, while typically small for our needs, provides the qualifications necessary to fulfill those needs. Thus, we decided to take the elements from bush planes and implement them into a larger scale aircraft.
To begin, we decided that the best course of action would be to fully estimate the dimensions of the aircraft. We did this by finding a picture of the DHC-3 Otter, which is an aircraft that we decided to base our bush plane off of, and creating the dimensions based off of that image. After that, we decided that our best course of action would be to find the empty weight of the aircraft. We did this by plugging a vector of empty weights into the max range equation and then solving the resultant range vector for our required value of 500 nautical miles. After this, after subtracting the crew weight and the payload weight from our calculated no fuel weight, we found our structural weight, which would be 11,296 pounds. Our next course of action, we best decided, was to find the airfoil of our wing. To do this, we need to calculate the Reynolds number. For the kinematic viscosity used to calculate the Reynolds number, we estimated it at 50 degrees Fahrenheit, which is roughly the appropriate value for Indiana. From there, we plugged in our appropriate values and found our Reynolds number of 5 times 10 to the 6th. From this, using data from airfoils.com, we plugged in our Reynolds number and estimated for our lift-drag ratio of 11.75, prior used to calculate the max range equation. From there, we decided on the airfoil of the NACA 0024, which is a symmetrical airfoil that we decided would be best both for our lift-drag needs and for ease of maintenance. After that, we decided it would be best to determine the engine characteristics of our aircraft. To do this, we must decide the power and thrust required for a range of velocities. For this, we used the power and thrust required equations and plugged in a range of velocities in which we estimated would be correct for our aircraft. And then shown on this slide, you can see the resulting graphs from these equations. After this, we decided on an engine based off of the minimum power and thrust requirements as shown on the graphs, and we picked the Pratt & Whitney R1535 as our engine. It has 2,062 pound-feet of thrust and 825 horsepower. This engine not only would allow us to meet our minimum requirements, it would allow us to exceed beyond us, giving us a maximum speed of about 199.5 miles per hour.
The final design concept Team A03 ultimately chose was an aircraft with the basic characteristics of a bush plane with a scaled-up model and a NACA 0024 airfoil. We decided that for this specific situation being addressed, the bush plane concept would have more benefits than flaws, one of those benefits being the fact that this particular model clears every requirement besides the load capacity of around 4,000 pounds. The size and weight limits are the only flaw we have evaluated, and we predicted that this can be addressed by the scale-up we perform. We have full confidence in our final design to succeed in its mission provided to us.
So, after introducing 3 potential models and discussing these 3 models, we decided that the scaled-up plane with bush plane characteristics would best satisfy the needs and requirements of the post-apocalyptic environment. It can take off and land with minimal space, achieve a maximum range of 1,000 nautical miles one way, and can carry people and other payloads. Through this project, we learned more about time management, the design process, how to properly pick aircraft components like airfoils and engines, and how scaling up a design does not necessarily scale up its results. Should this project be continued, the team would next develop more detailed models in a program like CATIA or SolidWorks, and would look further into the lifespan of the aircraft given the operating conditions.
And that was like, wow, that was a pretty fun
Presentation.